Hello students. In this module, we will be starting the first lesson of 7th standard syllabus, integers. So let us start with introduction. We have learnt about whole numbers and integers in class 6. We know that integers form a bigger collection of numbers which contains whole numbers and negative numbers. So let us talk about whole numbers and negative numbers. You can see that there are two collections of numbers in the image that they have shown here. So some of them are negative numbers and some of them are positive numbers. Whole numbers are nothing but numbers which do not contain fractions. So numbers such as 1, 6, 9, etc. which do not contain fractions are whole numbers. They are always positive. Okay? So 0, 1, 2, 3, so on forms the collection of whole numbers. However, we also have negative numbers which are not included in whole numbers. So numbers such as -5, -7, etc. are negative numbers. The whole numbers and negative numbers together form integers. So here we have a Venn diagram that will help us understand this easily. We have two sets here. One is the set of whole numbers and the other is the set of integers. We can see that the set of whole numbers is contained inside the set of integers. This means every whole number is an integer. But if you take a look here, we see other numbers, negative numbers, which are not contained inside the whole number circle. This means that integers contains other numbers which are not included in whole numbers. These are the negative numbers. We can understand this better if we take a look at the number line. So as we can see here, this is called as the number line. It is a very simple representation of the numbers. Here we have 0 in the middle and we have the numbers that are placed equidistant from each other. So as you can see, numbers that are less than 0 are extending towards the left side and numbers that are greater than 0 are extending towards the right side. You can also see that we have two arrows that are present on either end of the number line. This means that the number system does not stop here. It means that it extends infinitely in both directions. So it's not like there is nothing beyond 7, right? If we go beyond 7, we have 8, 9, 10, etc. So that arrow indicates that. So anything including 0 to the right side is the set of whole numbers. So this we have the set of whole numbers and the whole set together forms the set of integers. Okay, let us go back. What are the differences you find between whole numbers and integers? So we just learned that integers contains both positive and negative numbers and whole numbers contains only positive numbers and 0. In this chapter, we will study about integers, their properties and operations. First of all, we will review and revise what was done in our previous class. Let us start with the first section, recall. We know how to represent integers on a number line. So we have just learned how to represent integers. Some integers are marked on the number line given below. Can you write these marked integers in ascending order? The ascending order of these numbers. So what they want us to do is they want us to take out these marked integers. So we have given -5, -1 and 3. And we have to arrange them in an ascending order. In an ascending order, you always start with the least number and then go on increasing. So first we have to start with the smallest number. In this number line, whichever is present leftmost is the smallest number. Okay, so minus 5 is the smallest number, and we can just go on adding the other numbers. So minus y, minus 1 and 3. Why did we choose minus 5 as the smallest number? So this is because among the marked integers, minus 5 is the least number. In case minus 6 was also marked, then we would have chosen minus 6 to be the smallest number. Okay. The next question. Some points are marked with integers on the following line. Write these integers in descending order. So descending order means decreasing order. Decreasing order, we always have to start with the largest number. So the largest number is the rightmost number on the number line. So we have 14. Then we should move towards our left. So we have 14, 8, 3 and so on. You can write the remaining numbers in the space they have given us here. A number line representing integers is given below. Minus 3 and minus 2 are marked by E and F respectively. Which integers are marked by B, D, H, J, M and O? Okay, so we have E that is representing minus 3 and F that is representing minus 2. Next, we have to find the integers that are represented by these letters. Okay, so for us to solve this easily, what we need to do is we need to start from the integers that they have given us and we need to fill out the number line. Okay, so to the left of minus 3, we will have minus 4. Next, we will have minus 5. So this will be minus 6. And this is minus 7. So I will let you fill out the right side of minus 2, starting with minus 1, 0 and so on. Okay. Then we need to find out the question letters starting with B. So here we can see B is represented by minus 6. So similarly, you can answer the other letters. Next, arrange 7, minus 5, 4, 0 and minus 4 in ascending order and then mark them on a number line and check your answer. In order for you to do this, first you need to arrange them in an ascending order. So ascending order is increasing order. Any order that starts with the smallest number and then goes on increasing is called the ascending order. So first you need to find out which of these numbers is the smallest number. That's right. Minus 5 is the smallest number. You can start with minus 5 and arrange them in an ascending order. Then you have to create a number line. So we all know that a number line is just a line which has numbers present equidistant from each other. We can use this example that they have already given us and you can draw a similar number line and then represent these integers. I will leave this activity to you. We can move on to the next section. We have done addition and subtraction of integers in our previous class. Read the following statements. On a number line, when we add a positive integer, we move to the right. Add a negative integer, we move to the left. Subtract a positive integer, we move to the left. Subtract a negative integer, we move to the right. So you might be getting confused why these are the cases. To understand this better, let us take a closer look. Okay, so to understand each of these cases better, let us divide up each of these scenario into two parts. So the first part is we either have to add them or subtract them, right? So whenever we are trying to add something, let us imagine that as a situation where we are walking on the right on the number line. Okay, so whenever we are adding something, we are walking towards your right side on the number line. And let us imagine subtraction to be walking left on the number line. Okay, So for example, if you are starting at 4 and if you want to add 1, you have to go to the right to get to 5, right? And if you want to subtract 1, you have to go to the left to get to 3, right? So let us imagine addition to be walking right and subtraction to be walking to the left. Next, we know there are two types of integers. One, we have positive and we have negative. Now, let us imagine that if we are adding or subtracting a positive integer, we follow the same direction as indicated by the addition or subtraction. Okay? You will understand this better when we take an example. For now, let us just know this. If it is a positive integer, we have to go in the same direction as indicated by addition or subtraction. If it is a negative integer, then we have to move in the reverse direction as indicated by addition or subtraction. Okay? So whenever we come across any of these four cases, what we have to do first is, we have to look at if it is a case of addition or subtraction. Okay? So if it is addition, then we have to walk right. If it is subtraction, we have to walk left. Then we have to look at the sign of the integer. Let us take an example for the first case. So the first case is the addition of a positive integer. For our example, we are starting with 4 and then we are adding the positive integer plus 3. Okay. So now we know that we have to start at 4. So let us start over here. Next, we know that addition indicates walking to the right side starting from 4. Because it is addition of a positive number, we know over here that if it is a positive number, we have to continue in the same direction. So we have to continue in the same direction 3 times. So let us start from 4. First one we get to 5, next we get to 6 and next we get to 7. So the answer to this question is this one is equal to the same thing as 4 plus 3, which is equal to 7. Okay. Now let us get to the second case. So in this case, what we need to do is we need to add a negative integer. Okay. So again, let us start with 4. We have 4 right over here. And we have to add a negative integer. So we know that adding a negative integer, we have to consider it in two parts. First, we know it is addition. So it is indicating we need to walk to the right. But after that, we see that it's a negative number. Because it's a negative number, we have learned that we have to reverse the direction of whatever we started out with. Because we were turning towards the right here, the negative sign indicates we have to reverse the direction and go to the left. So we have to start at 4. 1 left is 3 and next 2 and 1. Okay. So this is the same as 4 minus 3, which is equal to 1. Sorry, it is equal to 1. Let us take the next scenario. So this is a case where you have to subtract a positive integer. Again, let us take this in two parts. First, we see that it's a subtraction. So that means we have to walk to the left as shown here. Okay, so let us find our 4. The 4 is right here and we have to start walking to the left. Okay. Next, we see the sign of the integer. Plus 3 is positive, right? So we have to keep going in the same direction as indicated by the sign of the integer. So we have to go 3 times to the left. So that will get us to 1. So 4, this example will get us to 1. That is nothing but 4 minus 3, which is equal to 1. Now let us consider the last case. This is perhaps the most tricky to understand based on your intuition. So hopefully this line of thinking will give you a better idea of why this is the case. So this is the situation where we have to subtract a negative integer. Okay. So when we are subtracting a negative integer, again, like our usual thought process, let us take this in two parts. First, let us find 4. Okay. Next, because it is subtraction, we have to walk left. Okay, so we are starting from here and we have to walk left. But next, let us consider the sign of the integer that we are subtracting. The sign here is negative. It is -3. And we have learned that whenever it is negative, we have to reverse the direction. So our direction was initially pointed to the left, but now we have to reverse it and start going to the right 3 times, where we'll end up at 7. Okay, so this is why 4 minus of -3 is actually equal to 4 plus 3. Okay, so this is equal to 4 plus 3, which is nothing but 7. Now let us take a look at the next exercise. State whether the following statements are correct or incorrect. Correct those which are wrong. When two positive integers are added, we get a positive integer. Okay, so when two positive integers are added, we get a positive integer. Is the statement correct or incorrect? So when we go and see our number line, whenever you're adding a positive integer, that is any integer that is to the right side of 0, and then again you're adding a positive integer to it, you just keep on going to the right side. Okay, so in that situation you can only end up with a positive integer, which is why this statement is correct. Okay, so the first statement is correct. Next, when two negative integers are added, we get a positive integer. Do you think this is true? So let us take an example. When two negative integers are added, let us say we have -3 and then we are adding -6 to it. So from our previous understanding, we have just learned that when we add a negative integer, we move to the left. Okay, so -6 here is a negative integer, and when we add it, we need to move to the left. That is, it is as good as saying this is equal to -3 minus 6. So the answer for this would be -9. And -9 is not a positive integer. Okay. So this is an example of where we prove a sentence to be incorrect by example. Okay. So we have an example where the statement is not correct. So we can say this statement is not correct. However, what is the corrected form of this statement? When we add to negative integers, we will get a negative integer. Okay, so when we add to negative integers, we get a negative integer. Next, when a positive integer and a negative integer are added, we always get a negative integer. Do you think this is true? I will leave this one out for you. Just think about it and try taking an example and figuring it out. Okay. Next, the additive inverse of an integer 8 is -8 and the additive inverse of -8 is +8. Okay, so in mathematical textbooks, it's actually usual for people to write just 8 when they mean +8. Okay, so we learned that integers have sign and value. However, you will always come across these things where they just write integer 8 instead of writing integer +8. So whenever there is no sign, you have to take it for granted that it is plus. Okay, so they are saying the additive inverse of +8 is -8. To understand this, we have to first know what additive inverse means. So additive inverse of any number is what you have to that number to get a 0. Okay? So for example, you have a number a with you. If you have a with you, the additive inverse is whatever dash such that when you add that to a, you get a 0. Okay, so that dash is the additive inverse. So what is it that you have to add to a to get a 0? The answer is minus a, right? So when you add minus a to a, you will get a 0. Okay, so this statement is correct because the additive inverse of plus 8 is minus 8 and the additive inverse of minus 8 is plus 8. Because when you add plus 8 to minus 8, you will get a 0. Next, the fifth one. For subtraction, we add the additive inverse of integer that is being subtracted to the other integer. Now, this statement can seem a little bit complicated. Okay, so let us take it part by part. Let us start with this part. Adding the additive inverse of the integer that is being subtracted. So what do you think this means? Let us take our example and find out. So for subtraction, so they are saying for subtraction. So let us take an example where we are subtracting a from b. So this is actually what this is saying. We are subtracting plus b from plus a. Okay. For subtraction, we add the additive inverse of the integer that is being subtracted. So what is the additive inverse of plus b? It is minus b. So this statement is saying this is equal to the situation where we are adding the additive inverse of b. Do you think this is correct? Yes, this is correct because we have learned that in both of these situations, we have to move to the left of A. Okay, we have to take A and we have to move B units to its left. So these two are equal to each other. So this statement is correct. Next, do you think sixth one is correct? Minus 10 plus 3, is it equal to plus 10 minus 3? I will leave this one for you. Let us go for the seventh one. 8 plus of minus 7 minus 4. So this might seem complicated. Let us take it one by one. So we have learned that this situation, we can simplify this to plus 4. Okay, so this situation, we can simplify this to plus 4 because minus of minus is plus. And this situation over here, where this operation of plus of minus 7 is as good as saying just minus 7. So this statement, it actually simplifies to 8 minus 7, 8 minus 7 plus 4. I'll just write it this side so that you can see better. 8 minus 7 plus 4. So this gives 5. Okay, however, we have what we have over here. So the right hand side of the equation that they have given over here, this is 8 plus 7 minus 4. This is not equal to 5. This is equal to 11. Okay, so this is not right. This statement is not correct and the correct answer is 8 minus 7 plus 4. This is the end of part 1 of the lesson integers. In the next lesson, we will continue on with the following exercises. I will see you all in the next video.